So the basis here is Keyline energy capture. So this is from the book, from the designer's manual, and originally from the book Water for Every Farm. So we're going to go through a little bit looking at pictures of actual properties, seeing if you can start to identify the key lines. So if you were to look at key point locations on topography, which is not exactly that easy for most people when we look at it the first time, it's just a bunch of squiggly lines, right? So, but over time, if you start to practice, you can interpret landscape and then see, okay, topography lines are just straight lines on contour. So the closer the lines are together, basically it means the steeper the contour. And if it's far apart, that gives a reference of it being less steep. So then people would interpret the contour based on lines. Nowadays that they can overlay the contour lines over a Google Earth map, it makes it much easier for us. So before, you had to interpret in like blank pages like this. But pretty much now everybody sees contour over an actual image, so much easier. So going back to the first picture when they were describing this, those 2 points are the key points, the little asterisks, and that's the intersection of a convex and a concave slope. So that's what P.A. Yeomans was trying to get us to identify. So what does that really come out to be? So there's those intersections of that convex and concave slope. And as I said in the beginning, the relationship between the height of the dam, which would be like a maximum height of 4 meters represented by the little stick, the water would go back. Where the water intersects to have the maximum water, right, with the least dirt movement. So if I start to move that stick up the slope, right, I actually would get less and less water storage. And if I pull it down, I wouldn't get more. So that point is the relationship where if I put the dam there, I get the maximum water stored in that particular landscape, okay? So he refers to that as the key point. So we're going to see if we can identify just by sight the key point by looking at pictures. So if we were to look at this picture and I'm driving down the road and I'm looking at some real estate and I say, wow, look at that. In some instances in like West Texas, this might only be $500 an acre, or in Australia, it's $1,000 an acre. It's not very expensive. Why? It's no trees. It's not very attractive. About the only thing when people drive by, they say, well, I guess we could put how many cows or how many sheep per acre. But what else would you do? But a permaculturist doesn't see that. So the permaculturist looks at that and, wow, I see the most amazing thing that you could ever dream up and draw. Because I see the key point. I see where I can put the pond. So if I'm with my little mouse, you see this little dip right there? And you see how there's like a little, it might be harder on there, but it's a little, the grass is actually darker because the water hits that, slows down. So if I come away from the key point with the relationship of the 4 meters and put in a dam, then that whole hill becomes a catchment. So when it does rain, and it does rain in that location, the problem is it rains and all the water goes off before it sinks in. So if I go and I put swales on contour, right, and then I capture the water to my pond, so at the upper side I see a big food forest on contour. I see in the center a nice pond. And actually there's 2 key point locations because I can store water at the mid slope. I can store water in a pond at the below end, so dig a regular pond, a dam, and even I could put a saddle dam on top. Utilize that for like micro hydro with a simple solar setup. So all of a sudden with 5 years and some earthworks, that's one of the most stunning properties that you could see. But what changed? Only the earthworks changed the property. The trees grow, but you can't grow the trees there without the earthworks. It'd be very difficult. Okay, there's probably at that property no water source, maybe no electricity. But with the advent of earthworks and a solar panel, I can make that habitable. So that changes that property. Here's another one, key point locations. So I look in the landscape and I see the topography. I can see that point. I have a relationship of the height. So let's say this was 4 meters. Then I move the 4 meters, okay, in relationship and imagine where it intersects, okay? So we just keep seeing these pictures over and over until finally, because it's not an intuitive thing. It doesn't like the first time you see a picture, you go, oh, wow. Sometimes, maybe, but not really. But if we keep looking at it, our pattern brains, the way it works, we say, oh, now I can see that, where we don't intuitively maybe see it. So here, key point location. So these are all properties, they're real properties where farmers have the opportunity if they wanted to store water, but they don't. You may just say that's out of ignorance. They don't actually understand how cheap it would be and the energy that they could capture over the life of the property. And even this farmer has his fields, and these are grapes, going uphill like the French technique, right? And French farms not doing so good anymore with the wine, right? Because pretty much all their topsoil erodes down, and over a period of time, because they're farming off contour, they create erosion, and it lowers the fertility of their soils. The other places that are more modern farms put grapes on contour. So they turn the trellises parallel or contoured, and they contour the trellises up the hillside versus them running linearly down. So in this instance, they lessen their erosion, and they increase the water storage capacity, increasing the productivity, and many people would state that the actual taste of the grape increases with nutrient density. So here we go. The key point is right about where the bottom of the hillside. So you see the trees. The bottom of the tree would be about the key point, and you'd have a dam in front. The dam would be right where where you see the trellises to be. Okay, so I come in there, I put in a nice dam. I capture that water coming down the hillside. Now I can do irrigation. I could plant a vegetable garden. I could start better tree systems, whatever I might want to do. And that's the difference of the properties. Poor cows standing there, don't even have a tree to get shade from. And if we look at that, there's nothing growing there. Even the grass doesn't grow very well, but it has a lot of water catchment. So we start to see the landscape as a catchment. And then if I look into the center, you can have locations. Location 1, location 2, and this property possibly even 3. So we're stacking ponds on top of each other through a landscape. Then you hold water. With the water, you can change the landscape. Without water, nothing. You just can't really do anything. Here's one, nice, and this would be very inexpensive. They wouldn't even classify this property as really well to even do herbivores because of the steepness. But if I can look at that and say, well, but that's a lot of water catchment, right? So that I might be able to get that water catchment for actually no value. They wouldn't value that property. I'd pay for this area, but that's almost included just for free. So at that point, I come in, and easily I can come, and with water, I could go up that hillside, trellis it with grapes. Okay, so Sepp Holzer at his farm in Austria, he grows grapes on rocks. So the rock outcroppings, he grows his grapes. He grows pumpkins, and they sit on the rocks in Austria, the rocks collecting the heat. And so he takes something that one farmer may see as invaluable or no value, and then he changes the landscape due to his water collection. So here we see, if we're looking down the valley, two key point ponds stacked on top of each other. So the key point is the back end where the water backs up to on each of those in relationship to the height of the dam collecting the water. So this person was looking, we're now standing at the top of the hill looking down versus we were before looking up. So we can start to see the top down, up, and even sideways profiles. So that we walk into a landscape and we say, wow, where's the key point? It's just imagining a relationship, right? And that's what's interesting about we can hold our fingers and move in front and use this to just say, oh, about like that. So very simple. Even to find contour, super simple way. If I just held my hand almost like this, and that stayed level, that's the contour line. From that contour line, you up. Super simple like that. Very, very easy once I can see. My contour is the first line I see on a hillside. Didn't change, right? At which time you go up. This is called a classic saddle dam location. So this would be where the saddle, like on a horse or between the humps of two camels, and you'd sit the saddle dam, you put in contour ditching that would collect the rainwater coming down and bring it to the saddle. And at this point, you'd have water accessible on two sides of a hill. Also, if let's say I had a pond at the bottom, again, I could have solar and pump water from the bottom to the top and facilitate a loop. So there we go. And then you can imagine, what can I plant there? What kind of garden would you like? What kind of fruit trees would you like, or nuts, berries? But with no water, these landscapes are very difficult to grow anything other than what is classified as a first successional grass and or weeds. So weeds we don't eat, and first successional grass we cannot eat. Okay, so we need to get this into a more the soils into a better landscape, and then we can work on that. So again, this is we start to look at landscapes. This is a large cattle farm. They go into the cattle farm and they keyline it, look for the topography. Where is the actual changes? And what we'll notice is land isn't just one way typically. So this farm has multiple pitches. So they keyline in each of the pitches respectively, come in to start planting with swales. So each of those lines representing a swale. They start the swale system. And if they want to increase the forest canopy, once we establish one line of trees with passive water harvesting, it's easier to walk the trees. One tree supports the second tree. It grows, you support it, and you walk the trees down the hillside from the water harvesting. Another one, 850 acre plan in California. It's got classic saddle dams. They've done lots of things there. So it basically comes to this concept. So this is from an actual class that they would do on keylining. So in Australia, there's lots of classes that you can go to take that actually you take the next step. I really would like to do this, especially if you're going to do it on any type of large landscape. It may be worthwhile going to a class to learn, and or there's people that consult that do this. You could also ask them to help you. But the neighbors in the back, so that property, dry, very brown, almost clayish color, very little grass cover. This person has a key line or a classic key point dam, and they're able to facilitate irrigation to that field. So then we can ask ourselves, what would you like to grow there? But without water, nothing. With water, whatever you'd like. So then the next question, where's your market? If it's for my personal consumption, that'd be a huge garden, right? And food forest. I'd take care of my family with just that small pond. Would support my family all year. And if it's a question of me supporting myself in the market to have money, right, I could then look at a larger. And what we find in these landscapes is typically you can put in many small ponds. So we're not talking about our dams. We're not talking about one big one. More than likely it's a lot of small ones. So that means that the first year I put in a small one with a swale, and then I could wait 2-3 years, I get some more money. I could put in a second one, and I could put in a third one, and I put in a fourth one. So maybe I do the full farm development over 20 years, right? And then I think about successionally, who am I going to give the farm to? The next generation has a farm that produces infinite amount more than what was inherited. So this is also a concept of inheritance, or giving the future to future generations. So that's a course. The people are standing there. They're actually reading the landscape on real topography. We're looking at pictures. But what's missing? Same thing. There's no swales. There's no dams. All the water that falls runs out and creates erosion in the gully. So they have an erosionary event tied to not slowing down the water. So this is called a turkey nest dam in this location. So right at the bottom, it's basically there's no topography. I can't really find a key point. It's pretty flat, and you just dig a circle to capture some water. The ridge dam, so as we were showing with the cushion, on the corner of the ridge, the swale brings the water and sits the water on the ridge. So this big ridge, the house classically offset to the side of the ridge, and with there, they can open a valve and they can irrigate whatever agriculture they'd like to do below. Another ridge dam, so the hillside, the topography, we see the dam looking from the side this time, and that big ridge and that water sitting up on a ridge. And now, when they let the water out, anything below you can irrigate. And you irrigate it without energy. So gravity irrigation is what people are trying to do. So they're trying to bring the water from the valleys to the ridges, and then from the ridges, they irrigate timing-wise the valleys. So this is a big ridge dam sitting in Australia. And ridge dam with a mixed species, because they're using the water for that to start what they describe as a mixed species. So more than likely it's some type of orchard, but a mixed orchard, where it's not a really good description of that, but it's not more so like what we might say a food forest, but not as intensive as we may think, and what we're going to look at as in food forest really close. They're going to have a more grid-spaced food forest. Here's a hillside dam, or what's called a convex or concave dam. So when we saw the ridge dams, and they have the swale on the hill bringing the water to the ridge, right? You can put a dam on the swale. It fills up, and then if it's full, the water at its spillway ends it to the ridge point. So that's a hillside dam in Vietnam. So you can see it This is called a sump dam in some places, farms, and this is, PA Yeomans didn't really show this, but sometimes you have like a gully that's already a big sump or a hole, a low spot. And so if you just put a dam onto the gully, you can actually fill it was described as a sump. So this is very economical. So they had a sump, they just put in a small dam, and it back flooded the sump. This is people experimenting. So it's called Keyline water harvesting, but on a catchment drains, and this is a offset contour. So what they're doing is going down the hillside, similar to how we would drive a car on a switchback up the hill, and they're moving the water off contour. So with lasers and the advent of machinery tied with lasers, we can actually accurately shape the earth. We probably couldn't have done this 50 years ago, 100 years very, very easily, but they've done this to 1 to 400. Okay, so in 400 millimeters, for instance, this is off by 1 millimeter. So the water is moving off contour, but very slow. We have to be careful with this because if it moves too fast, you could create erosion. So they've designed it to switch the water back down the hillside, okay, off contour. So this is more experimental, but with these systems working and with the advent of modern technology, this is making the ability to grow food in places that was not accessible to, let's say, modern agriculture. So this is the water, and you see the slight ripples, so it's off contour. When we see regular swales, it doesn't move. The water rises in what's called a tide line. So when the water comes in, it goes up, and then it soaks in and goes perfectly down level. So you just see level marks of where the water was soaking in. Okay? This is a ditch, basically, and a ditch is off contour. So the water will flow to whatever the amount the ditch is off contour. So the more off contour, the faster the water goes. The more contour, it doesn't move. If we do this, then we start to think about taking that concept and bringing it into more of our plans and designs with trees, access, okay? So we'll get into this design aspect more with the food forest. But here what we see is there's a road on a hillside, facilitating a swale road on contour. And then they lay out the trees, so this is mixed trees. And the tree spacing, that again we'll go in more detail in the food forest, but the size of the tree in relationship to the different type of tree. So each tree has a diameter and a height. So we have to then understand the growth of the tree over its life cycle. What is its max height and max diameter in relationship to the different tree that's planted next to it so that they have space to grow. And this would be planted on contour. This is a very small section, but each time that we switched back down the hillside, you'd see this probably pattern replicated. So you can create like a micro pattern of trees and then replicate that each time the track is done. So how does that look? Well, here's the road. The swale is on the upper side of the road, as we see with cars. It would fill up. There would be a pipe or a catchment, okay? That would bring it under the road if it was full. Then on contour, they plant the trees. So this would be like designing it. What trees do I want to plant? I need to know their spacing so I can figure out when they're mature, how far to plant them apart. And then I come back and I look at understanding the placing, the spaces based on diameters, okay? In relationship to different species growing at different rates and having different diameters. People ask, can I cross a swale? What happens if the swale and my road is not on contour, my road's off contour, my access doesn't afford me to access on contour? Well, Raktamachat's access is directly perpendicular to contour. So we drive up and we cross the swales. At the swale crossings, you can put in a pipe so that the water would come in, and when it goes up, it can go sideways to the pond. So our swales fill up, come across the road to this ditch that brings it into this pond. When you have a big dam, if you want to have an overflow that's not going to be, it's called a level catchment or a level spillway. It needs to be very wide, typically maybe 5-6 meters wide and perfectly level. You get grass to grow on it so that when the water floods, it comes up very small, like 1 millimeter, 2 millimeters is running over. If it's too narrow and it rains too much and you have too much inflow, the water will come up and it'll go across too fast and cut and cause erosion. So if you're going to have a narrow spillway, you would have to put in something like rocks or cement. If you don't want to do the rocks or cement to stop the erosion, then you can do what's called a level spillway, which is very wide and dead level. So here we see what is described as a level spillway overflow or catchment drain. Many people use different words, but the concept being that the water rises and just barely flows over, and the grass, like a pinball machine, is slowing the water flow down. It has to get through all the grass, and it doesn't have erosion. Once we start to see contour, and when we do our exercise in the morning, it comes more to life. So this is just how learning is, and why in permaculture we also take our inside concepts and bring them outside to touch them. So when we start to use our A-frame, right, we use our site level, our string lines, and we physically walk contour, then this comes together, and you can actually find contour. You don't even really need equipment. So people that have been doing it for a while, they can see the contour. So for instance, a person that's driving a tractor, the Keyline, he will find the first place where his tractor is and drive on contour, which is simple. Can you, if I put you on the side of a hill, really steep, and I said, don't walk uphill, don't walk downhill, walk across the hill, would you be able to do that? So you can see up or you can see down, and you can find a line across that hillside without going up, without going down. So the person on the tractor reasonably can do the same thing. So once he drives the first line, then the next he turns around and he can follow that down the hillside. So this is this is the picture from the book trying to explain that. If we see a real picture, which they didn't have when permaculture came out. They couldn't print color pictures in the books, okay? So you don't see many in the designer's manual. But now with the advent of computers, it's much easier. So here, this is called pattern plowing, or by the seat of the pants. So the operators drove the tractor, he went up to the top of the hillside, and he drove on contour, and then he followed that without a level or without a survey. He didn't walk an A-frame, for instance. He just drove slowly without going uphill and without going downhill, and then he facilitated making what I would like to think of, if you don't like the word keyline, think about micro swales. Just a lot of little swales versus one big swale, okay? If we do this is farms, a few farms, but this is farming on contour. You see the lines versus what we traditionally see as square, and people taking topography and doing a lot of energy to try to make the farm square and flat. So the farmer pushes dirt around, makes square and flat. And another farmer here, which actually he had one farm and it looks like he bought the second farm. So he's actually probably getting more profit because he's doing less work. So why would we want to do these things? Well, we're farming with nature rather than against it. And if we do that, we use less input. And if we use less input, that comes to our bottom line, and we have higher profit with less input. We don't use as much fuel. We don't use as much energy, right? We don't have to pump as much irrigation. So these farmers are actually winning or beating the commoditized farming. But two things they're doing. One, they're farming with nature on contour, passive water harvesting, and they're also not farming commodities. They switch to not trying to compete with a guy that has a 40-row combine doing grain corn, for instance, right? That guy, it's too hard to compete with him. They have too much capital, too much equipment, too many loans, okay? So you'll be looking for more plant systems that are a little bit more labor intensive. That means that you can't mechanize it. So if there's some type of mechanization tied to a particular plant, that makes it really fast go into commodities. And then they do it on big scales because they can mechanize it. For instance, one man in the US, it takes one man per 1,500 acres to do grain corn. Two men do 3,000 acres, okay? Well, if you're trying to compete with that guy without big tractors and all that, you can't do it. So we're not looking to try to compete with commodities. Besides, the foods tend to be processed. So those things get commoditized. They then get so much volume, they process it. Farmers markets, you're not going to see those things, right? So you might look at sweet corn. So corn is not a bad product, but I want to have sweet corn. I don't want to have grain corn. And these are things that were more non-mechanized.